With that, I want to go ahead and introduce today's presenter, and I want to invite my friend Stefano to turn his camera on. Stefano D'Andrea is an industrial graphic expert. Since 1989, he has dedicated his professional activity to the flexographic process, from design and pre-press to plate making and printing. Stefano has covered roles of technical support to sales, product management, business development, education, and technical training. Since 2017, he has been exclusively dedicated to technical education in the flexographic process and consultancy as an independent professional. Stefano is an active member of the FQC committee and the FIRST committee, and I'd like to welcome him here today. Stefano, thank you, my friend. I'm going to let you take it away from here. It's all yours.
Thank you. Thank you for the introduction, Joe. Thank you, everybody. And welcome to this FTA webinar. Let me share my screen, continue from here, and share, and we should be set, right? Is it okay?
Yes, yes, we are good.
Okay.
Thank you.
Perfect. So, welcome. When I came across this topic, I thought it was really very interesting because it really gives a possibility to discuss and cover certain important aspects within the Flexo production workflow. So let's get it started.
Hey, Stefano, you forgot to introduce me.
Oh yeah, I will have a friend helping me in this presentation. He will ask questions probably. I hope it doesn't bother you too much.
Thank you.
So I wanted to start this session with a provocative affirmation of the title, where color management is not pre-press. Wow. Well, I would say it's not entirely pre-press. In fact, when thinking about color management, one often thinks about experts in pre-press, consultants, nerds that play with those color profiles, compensation curves, measurements with those spectral photos, something. And this is possibly just one part of the game, because everything starts from the printing press and returns to the printing press. Color management heavily relies on the consistency of the printing system. So this is provided by a correct calibration process, and it is described with numbers. What are these numbers? These numbers are called characterization data, and they are the basement of the ISO norm that covers flexography. We're talking about this 12647-6. Think that this was the first norm of this 12647 series to require that the color of the printed product match a characterization data set or a printing condition agreed upon the provider and the receiver. So for the first time ever, we do not have color aims to match, but we need to match a data set. This data set, the characterization data, comes from the printing press. It describes the characteristics of a printing condition, and it represents the basement of color management for Flexo. Because pre-press work is done according to printing system characteristics. Therefore, color management and any pre-press activity will be a success only when working within a controlled system and a consistent printing condition. If printing characteristics change, then of course pre-press would refer to a different condition.
Oh, thus output results could be unexpectedly different.
Correct. Correct. You cannot expect the same results. But what does pre-press do for color management? Well, pre-press is extremely useful, but we need to make sure that we don't confuse color management with color correction. They are two different things. Color correction is meant to change the appearance, making it different, maybe better, reducing or eliminating the defects. When you set your white and black points on sharp mask, contrast adjustments, dominant color correction, or cleaner drop shadow, well, this is correction. Color management does not correct or improve the image. It maintains the aspect of one image, good or bad it is. Of course, we face challenges in all this, and we know them very well. When we want to reproduce a digital image on a different output device and maintain its appearance, the appearance that we perceive from one device should match what we perceive from the other. And when it comes to monitors and printing, we know that we may have to accept some compromises.
You are right, that was much better on the screen.
Yeah, we heard that a lot of times. So this happens because every input or output device that deals with color, be it capture or reproduction, will manage the colors in a different way. Of course, we can compute the characteristics of every device, and the purpose of color management is to align as much as possible the reproduction capabilities of these different devices in order to, let's say, translate them to a condition of common vision. Therefore, we try to provide the same visual appearance by relocating each and every color coordinates within the different gamuts.
Wait a second, what do you mean by gamut?
Okay, by gamut, we mean a spatial distribution of colors. So if we're talking about one device, it's the totality of colors that are reproducible by that device. It's a monitor, a printer, represented in a color space. If we're talking about one image, it's the totality of colors composing that digital image, represented in a color space. So if we take one image like this, it is composed of pixels, right, of several colors. If we can see the colors, it means that they are reproducible on our screen. Very easy. So here we can see all the pixels of the image of the rose contained inside the 3D shape of a color gamut of one Adobe RGB monitor. And here is a gamut of a Flexo press, well, a rather small gamut here, inside the Adobe RGB. This graph shows that the monitor can display any color that is printable on that press. Color gamut is the volume that contains all the colors that are reproducible by a given output device, and it describes how a device reproduces or captures color. A color profile is a file that contains more information, different information that is used to calculate colorimetric transformations using color management module, what we call it CMM, of our computers. So a color profile is a container of information. It describes the characteristics of a specific device or of a group of devices. When we say sRGB or ISO-coated, okay, we're talking about a group of devices regarding how this device reproduces colors.
Okay, but what exactly would I find inside a color profile?
Inside the color profile, we have a lot of information. We have characterization data and formulas, or better, we have tables and parameters that will allow us to do the math and convert colors between different devices. Characterization data describe the printing condition, so this depends on the components that influence the color reproduction. So, we know perfectly the plate, the analogs, the plate surface texture, the cushion tape, the ink, the substrate. We know the story. Then we call them direct and inverse tables that will allow us to convert the values such as CMYK to what we call the profile connector space, such as LAB or NBAC. So these tables allow to know what LAB value correspond to any mix of CMYK values that we measure in the patches of the color chart, and inversely what CMYK values are required to obtain any given LAB values. And then we have additional parameters to define how the color mix of CMYK, if it's a four channels profile, is built. Like, where do we start with the black? How much GCR or UCR? What is the maximum total area coverage? Well, we'll see that in a while. And every device will reproduce colors in a different way, but the same color build, okay, parameters can apply to different conditions, or different parameters can apply to the same characterization data to calculate different profiles that manage color in a different way.
Interesting. Can you explain better these characterization data?
Okay, so let's keep these parameters on hold now and focus on characterization data first. So we say that ISO 12647.6 speaks about characterization data. So let's see where they're coming from, who delivers them, how can I best use them, the information that is contained inside, and how to use them in production. First of all, characterization data is the result of the system calibration process, preceded by optimization and fingerprint. Basically, characterization data are the numbers that we measure on the color charts, okay? So maybe not just one single set, but hopefully many measurements that are then averaged and possibly evaluated, maybe corrected, smoothed. Who delivers them? Whoever does the measurements and builds the color profiles. So normally it is the prepress department or your external repro house. And these numbers show the relationship between the input nominal values, so the CMYK values of each patch, and the output values. Here we're showing LAB and spectral values. And as an example here, you can see the first batch of this characterization dataset that has CMYK 10, 20, 20, 20. So it's kind of a warm gray, okay? And from these numbers, we get all the information about solids, densities, TVI, curves, gamut. And these are the values that we use on our press when we do quality control during production. We printed those values, those patches during the calibration. Now we have to match the same values in production. So characterization data are extremely useful to understand how you're actually printing. Your TVI curves, the gamut you cover, it's all in the characterization data. And these are curves and gamuts coming from characterization data.
Who, my friend, those are very bad TVI curves and gamuts. Do you really print that way?
Oh yeah, well, that's how I printed during the characterization run. So if profiles for separations and proofing were built on those numbers, well, maybe it would have been better to take a look after Repro did the measurements before building the profiles. So here I have a question for you, and Joe, if you can help and launch the first poll for our audience. So the question is mostly for the printers. Do you own your characterization data? Do you use them?
We'll give it a minute there, Stefano.
Do we leave some time for answers?
Yeah, we'll leave it open for about another 15 seconds.
Yeah. Yeah, the thing is that maybe for sure we will have people that are currently using everyday characterization data, people that are running characterization runs every week, every month, maybe others that fully rely on the work of the repro house.
So okay. There are the results. There are the results there, Stefano.
What is it talking about? It's funny.
That is fun.
Yeah, it's good. I mean, it's good, and I'm happy that nobody answered yes. It should be somewhere in the mailbox at least. Well, then they know what we're talking about and they use it. Okay. Yep. Yeah.
All right.
I think okay. There was a repetition of the second question. Anyway, it's okay. So let me go ahead here. How can we take a look at what is inside the contents of this characterization data? Well, there are tools around that provide a report from raw measurements, or they can extract this data from the profiles. On the screen now, you see a report from the profile ISO-coated V2 that is built on FOGA 39 characterization data. This is very useful for the printer to track all the output characteristics of a printing condition in terms of solid color values, halftone values, TVIs, and any other parameter that will be used for quality control in the production process. So characterization data actually describe how you print or how you intend to print. What are the colors of the inks? What's the substrate? What dot gain? And we can either share the specific characterization data of your very own printing condition, or agree to use a generic set of characterization data, provided our printing system is aligned to such values. So there are different standardized or generic printing conditions. In Europe, can I say unfortunately, the industry is still working with FOGA 39, that is 20 years old. Now, and although we hear more and more about more recent FOGA 51 or even CRPCs, In US, it is most common to hear about the 7 CRPCs from ISO 15339, and more often CRPC 6 that is almost equivalent to Grackle 2013, almost, because they're not exactly the same. They have the characterization data is the same, but the black generation is slightly different. So that is how you are expected to print. And this is expressed as output intent. When you open one image and you see it is tagged with the name of CMYK color profile, it means that this image, as you see it on the screen, has been prepared for that printing condition. The separation channels, CMYK, expect to find on press the values contained in this characterization data used to create such a profile. So if I open one image and I see coated photograph 39, what does it mean? It means that this image is expected to print on a sheet-fed offset press with screen ruling 150, 200 LPI onto a glossy or matte coated paper.
Hey, wait a minute. I don't print in offset. I print in Flexo. So do you mean that I can obtain what I see on the screen only when I use those offset settings?
Yes. If we don't print in the same conditions, the result will be different. Okay, so this must be very, very clear. And you name it, print settings and components and variables in Flexo are far different from offset. Okay, we do not have the same behavior of our printing system. Okay, and where will you print then? Are you printing in Flexo?
Okay, you want to see my characterization data, don't you? Here they are.
Here's the characterization data report from printing one Flexo printing condition. And maybe, yeah, you can see here the solid values, the TVI, maybe the TVIs were not properly adjusted here. I have a 40% TVI on black, magenta, and yellow, 30% on cyan. Well, okay, so if you print it like this during the characterization, I expect you to print exactly in the same way when you print your production. Maybe next time we do a recalibration of your printing system, probably we would pay more attention to these values. And obviously, if the original separation was prepared for offset, we cannot expect it to print correctly in your Flexo condition without changing something. And we have two options here. Tweak and trick on your press until it delivers the same numbers described on the offset characterization, or change the file with color conversion. And of course, option 1 might not be so easy. So we need to change the separation so that when printed onto our Flexo system, the result will be much similar to what was expected in offset. But of course, we won't do this manually with Command M. We used to have Apple M on Photoshop by pushing and pulling the color curves and clean here and a bit there. No, we don't do that. As well as we really don't want to run after the results by tampering with press settings. We don't want to stop the press and change analogs for color matching, or add a drop of yellow in that magenta, or change the mounting tape for cyan. So the list of the don't do these things could be even longer.
Well, I'm afraid I've heard a lot of those phrases.
Yeah, remember that prepress relies on the consistency of the printing system. And once again, ISO standards come to our aid. So here we have the ISO TS 10128 technical specification, and it describes 4 different methods to convert the colors to match a set of characterization data. So we have the adjustment of tonal values, TBI curves, dot gain compensation curves. We can work with near natural scale calibration. We can use the color optimized correction curves. We know the system under the name of given by Chuck and Bill, the optimal method. Or we can use multidimensional transforms with a repurposing with device link profiles. Be careful, because all of this works only if your printing process can be repeatedly restored to a prior printing condition, and that condition can be maintained both within a run and between runs.
Stefano, we have a quick question for you, if we can take that. Who owns ICC profiles and characterization data of my printing system? Could I freely ask them, then freely distribute them?
Okay, distributing an ICC profile may incur into certain patents, but characterization data are just numbers. So whenever anybody is asking to know the color profile of your printing condition, you are free to distribute your characterization data.
Yeah.
The characterization data describe how you print. Other parameters, and we will see this in a while, inside the color profile may be not some little secret spicy from prepress that they can adjust certain little values and they can make a condition better working in certain environments or what else. So sharing an ICC profile may not be the right choice, but it is for characterization data. So the best thing is to have a tool to provide a report of your characterization data and say, so this is how I print. Okay, you don't need to have my color profile because actually the color profile will determine how you make the separations. But you want to know how I print. So this is the we have a lot of brand owners today. They want to know they can evaluate the ability or the capacity of a printer by checking their characterization data. I hope I understand. I answered to the question.
I think you hit it. Thank you, Stefano.
Okay, so the first three methods are described in 10.128 make use of these bidimensional transforms so that they are curves, okay, input-output curves. Typically, they're going into the RIP, but color management refers to the fourth option and provides three-dimensional transforms from one 3D space to another 3D space. So in order to move from one source to one destination profile, well, we need to have them both. And when managing this translation or this transformation in the correct way, we can expect coherent results in printing.
So how do we convert colors between different spaces?
Okay, so let's see something more technical. That's not always very easy because some colors that exist in one space do not exist in another space. A typical example is when we convert one image from RGB to CMYK. For sure, you know that a bright green, I call it the Excel green for the when you color in green the cells of your spreadsheet, can be displayed on a monitor, but it can't be printed in CMYK. Okay, we don't have that bright green in our inks. But maybe you don't know that the color cyan, the ink color cyan, cannot be displayed on the majority of our sRGB monitors. Okay, so that's another limitation. So sometimes we think about color, but we are not considering all the connections. And here we see the colors that are printable in CRPC6, the colored gamut, and what is visible or capturable in sRGB. So it's the white transparent. The same color can be captured by any RGB camera with certain values, displayed on a monitor with different RGB values, same color we perceive, printed on a proofer with other CMYK colors, and finally printed on a press with other CMYK colors. And our perception of that color is still the same. So colors described in RGB or CMYK depend on the characteristics of the output device. That's why such color modes are called device dependent. That's why you never, ever describe any color by RGB or CMYK values alone. You need to refer to a color profile.
So I can't say my brand color is 70% cyan and 50% magenta, can I?
Correct. You cannot specify a color by saying it's 50% black. No, without a reference to a color profile, RGB and CMYK values alone are totally useless. So in order to convert colors between two device-dependent conditions, we need to translate them into a device-independent method like LAB or XYZ. That's how colors are transformed and converted. Let's hear how it works. I take a shot with my camera and one pixel records RGB values 78, 74, 140. That would be a profile for that camera with its own characterization data that converts RGB values in device-independent values. In this case, it's XYZ. When I display that pixel on a monitor, the profile of the monitor will search for those XYZ values and will return the corresponding RGB values for the screen to display the same color, or very similar, that was captured by the sensor of the camera. Okay, so these are these direct and inverse tables, how it works. Same thing happens when I print. Within the profile of the printing system, the CMM color management module will search for those XYZ values and will return the necessary CMYK values to reproduce that color. It's easy, okay? So, but what happens when the source is bigger than the destination? So, and the destination gamut here is smaller. Some colors cannot be reproduced in the destination. So what happens to these colors? So during conversion, we have what we call the rendering intents. So we can squeeze all the source gamut to fit in the destination. And this is what we call like perceptual rendering. Or we can clip or remove the exceeding colors and reproduce only those that are available in the destination gamut. There could be much more to say, but I would just keep this example very basic as it is. But color conversion today is just a click, unfortunately. And this is what we do when we take our photo from RGB to CMYK, and we do click and it converts to CMYK. But we do it without thinking about what happens behind the scenes inside our computer. In the past, we used to make separations with color filters and panchromatic films in the darkroom with crystal screens on the super auto vertical camera. We were making half toning, we were doing positives and negatives, chemical processing.
Stefano, we could tell your age by the way you describe all this.
Yeah, I come from those analogic times where we had limited possibilities to change the structure of primary colors in the separations unless some manual retouching done by artists. Photomechanical activities were done by real prepress experts with a particular feeling of color. Today, we don't have that, but we can play with numbers. Okay, so we have a different ways to generate the color in separations for printing. The same color can be obtained by different, let's say, recipes, okay? Different quantities of CMYK channels according to specific rules. Remember, when describing the color build parameters in the profile, that they can change the composition, in particular, the generation of the black channel. Here you see how we can obtain almost the same brown with different compositions of CMYK and different ink consumption, total area coverage, the last column TAC. So, okay, so there is a difference in consumption of ink. When a color is converted from RGB to CMYK through LAB, the quantity of black is calculated according to user specifications that are defined in these color build settings. Here's an example of 3 different color builds obtained with the same characterization data, resulting in the same color when printed in CMYK. The central one is actually in CMY, so just 3 colors. Okay, so as you see here, if I have a 4-color separation and I want to make it in 3 colors, I will not delete the black channel. I have to reconvert the separation in 3 channels. So here's another poll for you. Okay, Joe, can you help? So what CMYK build would you prefer to print this brown?
Can I answer the poll too, Stefano?
Oh yeah, the question is for anyone involved with the Flexo process.
There you go.
Great.
For the record, Stefano.
Yeah,
they don't see that, they don't see it in real time like you and I do. That's why, yeah. That's
Okay.
No, when I end it, I'll share it. So we'll give it another minute, another couple seconds.
Okay, when you answer to this poll, think about the ink consumption. Think about what happens with registration, having 4 colors in registration instead of 3. About trapping, about drying, about energy. So there could be many reasons why you would select one rather than the other one.
Okay, I'm going to go ahead and end that, and we will bring up the results for you. There you go, my friend.
Okay, okay, and I'm happy to see that everybody prefers not to have cyan in the composition of brown. That's good. So how do we make these color recipes? Do we have some person on the screen watching a monitor and touching the? No, we don't do that. We do it in a we define the color build strategy in agreement with the printer, and whoever builds the profile will enter the necessary parameters in the profile creation. Here we see how the GCR works, gray component replacement. So a quantity of black replaces the quantities of CMY in order to obtain the same gray color equivalent to that quantity of black. And here you see what's a 0% GCR or 100% GCR or a 50% GCR that leaves some cyan in the separation. So different quantity of black is not only meant to use one ink instead of 3 to reproduce the same color. While saving ink, we also obtain reduced overprint and trapping issues. We reduce the energy for drying and curing. It also provides cleaner separations with less problems for color balance in printing, reduce ink risk of effect due to misregistration. In general, we would expect less press down time and less wasted material. Another black generation technique is the UCR, under color removal. This works more in the darkest areas of our images. This method is, I would say, more appreciated with printing systems with a higher stability, and it provides an extended contrast with darker shadows and blacks. And the structure of the black channel will mostly design only the darkest areas, creating what we call the skeleton black. All these adjustments are normally available in any profiling software with sufficient editing possibility. And the editing of these settings is possible only if the profile contains the characterization data. If the profile is not compliant and editing is not possible, then the solution is to retrieve the characterization data and build a new profile.
You spoke about conversion from RGB to CMYK, but we normally need to convert from CMYK to CMYK, and there we have some troubles.
Yeah. In the world of packaging, the original files are normally supplied already separated. So it is more common to require a color conversion between similar color modes, CMYK to CMYK. So origin, CMYK, destination, CMYK. And when we convert one CMYK separation to a different CMYK profile, the CMM will convert to LAB. And then it will search for the CMYK values to match those LAB values. Yes, the color will be probably identical, but you might find unwanted channels in the separation. A black 100 would be split into 4 channels to reproduce exactly the same black color, but with cyan, magenta, yellow, and black printing together. So would you print with a text with the 4 inks in registration?
No way. That would cost a fortune in pre-press corrections.
Yeah.
How can we avoid this?
The way to avoid this is to make the separation in a different way. So we use a different type of profile. We call it device link profiles. Basically, it's a connection between 2 color profiles, and typically it's CMYK to CMYK. So we have one source and one destination, and we define the rules to convert the colors. We call them exceptions. Example, if there is 100% black, okay, or only black, a gradient of black, leave it as it is. Don't add other colors, okay? If it is a single primary, don't add other colors. If it is a secondary, like red, magenta, and yellow, adjust. My internet connection is unstable, so I hope everything is okay. Adjust the percentage, but leave it magenta and yellow. Similar for duplex, so it's black and primary, or triplex and black and 2 primaries. So the color conversion will work on all the elements, images, vector, text, and it could do the complete files or just selected elements, depending on the tool you're using for conversion. So here is an example with a test file with black 100, gray 25%, some primary and secondary colors at 50%. A direct conversion to a different ICC profile would provide the best possible color match following these formulas of the color bead that we have in the destination profile, GCR, black start, and so on. For sure, a color like a 25% gray of the original would be more difficult to print, more unstable on the press, to be kept in balance with 4 primaries printing all together, right? So 22, 15, 16, 2%, difficult. As soon as you have some instability on your press, your color may drift. Any little press deviation would make it difficult to keep a very nicely balanced gray. Gray printed with black, easier, okay? It's easier to print with a single channel. A device link conversion, having set the right exceptions, only black will remain only black. 100% text black remains 100%. 25% black goes to 23 here. If I had a green, it remains cyan and yellow, different percentages, okay? Because it provides the same color. It will maintain the same visual appearance of the original file. You might be thinking that all of these parameters, exceptions, conversions must be in the hands of prepress. Well, yes, but everything must be agreed with the printer and rely on a consistent printing condition. Remember, your printing process shall be repeatedly restored to a prior printing condition, and that condition shall be maintained both within a run and between runs. The printing press is not a painter's palette where you freely adjust and change colors every time. Prepress has no magic wands. You aim to a certain result, your output intent. If your system does not provide such result, prepress will just compensate the actual condition to match the desired results. But if actual press behavior changes, then the prepress compensation is worthless. That's why when we say color management is done in the press room, it doesn't mean to run after a result by tempering, tweaking, and tricking on the press.
So I should not change analogs or correct minds to get results?
No. You should quality control your production and results will come. Therefore, the essential condition for correct color management is to have reliable characterization data coming from a calibrated, well-calibrated printing condition. And it means that went through a good optimization and a good fingerprint, adjusted within reasonable tolerances, and guaranteed to reproduce consistently over time the same result. Color profiles calculated from such condition will be reliable for separations and proofing.
Okay, now I understand why color management is not only pre-press.
Correct. Remember that color management is completely useless if you run after your results by tampering with the output conditions of your printing press.
Thank you very much for your attention.
Yeah, thank you very much. And I hope it was helpful for you and I give you some things to think about.
Yeah. Thank you, Stefano. It was a great presentation. You did a wonderful job. Could you bring your screen back up again, please? Uh-oh.
I lost. Okay,
Did you lose that?
I lost you for...
Can you bring your screen back up?
Sure.
Yes. I just wanted to say a couple things to the audience. You know, a lot of times people reach out to us at the FTA for a copy of the presentation. There is Stefano's email address there on screen. We'll have him leave that there for a moment so that if you need to reach out to him and ask any questions regarding the presentation or anything like that, please feel free. There is his contact information. Again, he was been broadcasting this from his computer, so we don't have it at the FTA. Stefano, let's leave that up so people can get it, but we have a couple questions for you. How do we instruct an agency to use the correct color workflow settings?
The agency can be instructed to provide the separations with a agreed generic standardized profile, right? So we work with CRPCs. So if the product will be in the range described by CRPC 5, okay, then we can instruct the agency to work and to do the separations, to do all the work in CRPC 5. And then we, as let's say pre-press printers, will provide the necessary color conversion from CRPC 5 to the actual color profile of our printing condition.
Good, good. And we have a couple more here, Stefano. If I always run Flexo, does that mean my run colors should always be mixed exactly as the last time? Or when the temperatures and humidity change, does that mean the mixture changes?
Okay, so these are two different questions.
Yeah.
I could answer first. Let me answer to the second part. The best investment you can do for your printing department is insulation. Okay, so avoid temperature and humidity changes. That's the best investment. Second, yes, if you define a color mix, probably here it is asking about a spot color. Okay, a spot color mixed with monopigmented basis in ink formulation. So yes, that's the formulation, and that's and you would quality control your spot colors. If it is a color separation, a color build, well, I know printers. I have one printer in the FQC group that he is busy every 2 weeks to check the characterization. So yes, you would check your characterization, and you would provide to your pre-press department any variation that could happen over time. So for sure, maybe from winter to summer, you may have some differences, but if you provide updates to your characterization data, whoever calculates the color profiles has the possibility to update, so to adjust them to, okay, so this is the previous color profile, this is the new characterization data. Maybe it's just a strip to hook only to the most necessary or the most relevant colors, and then you can update the profile.
Good. Okay, we got another one for you. When we run the optimization, do we do it fully linear, or do we create a bump curve in the 1 to 10%?
So the optimization should be with linear with the capability of the plate. I mean, the bump curve doesn't happen after printing. The bump curve happens in plate making. So the question is, the bump curve is something that needs to make the plate having a certain small elements on the plate that would measure like I don't know, 0.5, 0.8, 1%, whatever. Okay, so what is the bump that I require to obtain a 1% on the plate? So that value happens, and that setting happens before printing. Then I print the plate with that 1% on the plate. How does it print? It prints 6 or 7. Well, that's so when you think about the process, you have to consider when to do every part of the process. I know many people used to take a plate without any bump with a let's say, can I say the obsolete method of bump curves? Because today with the latest plate technologies with flat top, probably nobody does bumps. But but the industry is moving towards the no bumps. And yeah, I know printers are printing with no bump, and then they're checking on the printout. I don't like that, because the bump curve is related to the plate characteristics. So it is the plate making characteristics that affect the value of the bump curve. While if you do it on press, you have plate making. So I mean the density of the black layer, blah blah, plus the conditions in printing. I prefer to split. In Romans, we're saying divide et impera. So, so keep them separate and manage them separately.
I got another couple more here for you. Why do you suggest CRPC 5 and not the ECI CMYK version 2 profile? Is there a specific aspect?
I discussed with Sergio so many times about this.
He's the one asking
it. So CRPCs are good when you already know the specification, how your final product, what your final product will be. Okay, will it be a newspaper, a corrugated box, a label, whatever. The ECI, the latest ECI CMYK, it's an exchange color space. It's a very wide color space, right? So it's maybe we could compare to the CRPC 7. So when you don't know what to do, you would take your RGB, convert it to a very wide CMYK, and then from that very wide CMYK, go to the smaller CMYK. So that's possible.
Okay, how about our final customers? Typically, the brands are asking for beautiful, fuzzy, vibrant, or crunchy colors.
Yeah, yeah. We should probably address these topics of color management to brands, and we spoke about this during our meetings in FQC, and so probably brands should be involved more in how to define or how to have proper expectations on the quality of their products. Yeah, crunch. I had that a crunchy green. They wanted a crunchy green. Yeah, crunchy green. In that case, it was due to color or someone that saw one image on a screen, and then they gave a color proof made on a very glossy paper, and the final product, guess what? It was a craft white, corrugated.
Just think how unexciting our jobs would be if we didn't have designers, right? Can you specify the requirements for ISO 12647 and how it impacts printing manufacturing?
Ooh, you
That's a
said that
good
you have a meeting.
quickly, we're getting running out of time.
Quickly. The ISO is built on the fact that you have to exchange characterization data. So it means that the printer has to demonstrate how it prints. Okay, when you have the characterization data, you can share with your providers, pre-press providers, with your customers, and all the other things like pre-press and will be based on the characteristics of this printing condition. So the impact is great.
Yeah, good one. Stefano. Hey, Steve Smiley's got to chime in here
Sure.
on your on the optimization question, and he says he prefers to pre-linearize plates for bump, but in optimization, look for SCTV. What are your thoughts, Stefano?
Absolutely. I fully agree. I didn't mention the SCTV. Well, I frankly call it CTV now.
Yeah.
If you watched my a previous webinar that I did about the natural plate compensation curves that are built on CTV, yes, I do pre-linearize the plate in plate making. So then I print it, and then I during the optimization I calculate the I call them pre-compensation curves. And after this pre-compensation curves, I can print my fingerprint, and I do extra if necessary compensation curves for gray balance or whatever, and then finally I can build my profile. Yes, I fully agree with Steve.
Yes. All right. Last question. Please give us 2 words about cost. Why is it recommended to invest in color management software and press characterization from printer to repro perspective?
But cost is 0 because they already do it.
Right. Yeah.
I mean, if you work with a pre-press agency and they ask you to print that color chart, and if the purpose of that color chart is just to show you, hey, your file on your press will print like this, you have to pay me a lot of money because I have to retouch all of this stuff.
Yeah.
That's not the purpose. So
No.
in order to do that color profile, color proofing, they are actually building a color profile. So the job is already done. The cost is already there. They don't have to spend more money, right? So they just have to, maybe the cost is the investment to understand, to understand how it works. Okay, maybe work with someone that can explain you and to guide you through the process of of introducing this process in your workflow. But yeah, so the question coming from Mauro, yeah, the cost is already paid, so there is no extra cost.
Yeah. Well, Stefano, that does it with the questioning. Once again, we want to thank you for taking the time and delivering this very important content. I think that it was well done. We really, really appreciate it. On behalf of the FQC committee, the first committee, thank you. And for all of our attendees, we want to thank all of you. Keep an eye on your email for Monday morning. You will receive a link to watch the recording. And with that, I would wish all of you a happy weekend.
Same from here. Ciao.
Ciao, Stefano. Thank you.